In this video, we're going to have a look at finding rules from patterns and tables. Let's start by looking at a simple pattern of triangles made from matchsticks. In the first pattern, we have one triangle using 3 matchsticks. In the second pattern, we have 2 triangles using 5 matchsticks. You can clearly see that we've added 2 matchsticks to get the second triangle. In the third pattern, we have 3 triangles, and again we have added 2 matchsticks to get the next triangle. We can complete a table of this data. In the first image of one triangle, we used 3 matchsticks. When we had 2 triangles, we used 5 matchsticks. And when we had 3 triangles, we had 7 matchsticks. We were increasing the number of matchsticks each time by 2. That is, the outputs increased by 2 each time. This is the amount we multiply by in the rule, and we can continue the pattern without drawing the triangles. So our rule so far is our output equals 2 times our input. Now that can't be the final rule, because if we take our input 1 and multiply by 2, we get an answer of 2, but we need 3 matchsticks, so we need to add an extra 1 for the rule. Now where is that extra 1? If we had a 0 pattern, you would see that we have 1 matchsticks to start with. So our final rule, if we let T equal the number of triangles and M equal the number of matchsticks, we would have the number of matchsticks equals 2 times the number of triangles plus the 1 that we would have started with. Now we don't always have to have a pattern to find a rule. We could be given a table like this. You can see that this pattern of outputs is actually reducing by 3 each time. Now you can't just look at 1, you need to continue to make sure the pattern holds. 2 to -1 would be going down by 3, -1 to -4 going down by 3, and you can see that the pattern holds. So here we have our output y equals -3 times our input. Now we need to check, is that the final part of the rule? Well, if we take -2 times -3, we get +6, but you can see the answer wants to be 5, so we have to -1 on the rule. If we go to if the rule was at 0, you can see that we would have had -1 here. Now we can pair these coordinates and plot them on our Cartesian plane. So at -2 we have 5. At -1 we have 2. At 0 we have -1. At 1 we have -4. At 2 we have -7. And finally at 3 we have -10. You can see that all these points lie on a straight line, meaning that our rule is linear.